This is video number 3 of the series of videos I'll be making on revision for the chemical world topic for Year 9 Science, looking at atoms, elements, and the periodic table. Let me now talk about writing chemical formulae. So let's look at covalent compounds. Covalent compounds, these are compounds formed from two non-metal atoms stuck together. When you take two non-metal atoms, stick them together, you get a covalent compound. Common example is hydrogen. We write hydrogen. Hydrogen exists in nature as H with a small 2, subscript 2. The 2 means there's two hydrogens. Okay, it looks like this, bonded together. Covalent compounds involve atoms sharing electrons. They share them. Sharing is caring, yeah? So electrons are shared, and that's how they bond. A chemical bond is formed by the sharing of electrons in this case, in covalent compounds. So this is hydrogen. Similarly, oxygen exists like this, O2, nitrogen, N2. These are gases. Suppose we need to write the chemical formula for this compound. Let's suppose I'll give you dinitrogen monoxide. How would you do this? Well, prefixes. So prefix number. You need to know this. Okay, 1, 2, 3, 4, 5. Oh, my bad. Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. Prefixes are used in place of numbers when naming chemical compounds. Mono, think of a monobrow. That's 1, yeah? Mono means 1. Di, think of dice. That means 2. Tri, think of a triangle. It's got 3 sides. 3. Tetra, think of 4. Penta, think of 5. Okay, pentagon has 5 sides. Hexa, hexagon, 6 sides. Heptagon, 7 sides. Octagon, octa, 8, 9, and 10. You get the idea, I'm sure. So dinitrogen monoxide. Dinitrogen means there's 2 nitrogen. Put the 2 down here as a subscript. This is convention in chemistry. You don't put it like this, you put it like that. Okay? Dinitrogen. Di means 2. Monoxide. Mono means 1. Oxide means oxygen. There's 1 oxygen, so you put as O for oxygen. That's the chemical. So you write the chemical symbols. So nitrogen has a chemical symbol of N. Oxygen, O. You don't put a 1 here. You can if you want, but it's preferable that you don't. Okay, in chemistry textbooks, that's how it's written. That's dinitrogen monoxide. Let's do this one. Let's do tetraphosphorus. Let's break this down. Tetra means 4. Phosphorus, chemical symbol of P. Tetra means 4. Put the 4 down here. Let's do another one. Let's do iodine heptafluoride. Okay, let's write the symbols first. Iodine goes first. It's I. So we'll write it from left to right. Okay, so iodine is I, goes first. Heptafluoride. Hepta means 7. Fluoride is fluorine. So F and 7 down here. Okay, iodine, heptafluoride. Let's do another one. Let's do nitrogen. Already done nitrogen. Let's do boron trihydride. B for boron. Hydride is hydrogen. Okay, whenever you see HYD or HY, hydrogen. H, tri means 3, so you put a 3 there. Try doing these on your own. Questions, I want you to do carbon, tetrachloride, carbon. I've done carbon. Let's do disulfur hexabromide. Nitrogen dioxide. phosphorus trichloride. 5 silicon disulfide. You can pause the video here if you want and do them yourself. Here are the answers. 1. Carbon tetrachloride. Carbon is C. Chloride is chlorine, Cl. Tetra is 4, goes down here. Number 2, disulfur. Sulfur is S. Di means 2. Hexabromide. Bromide is bromine, Br on the periodic table. Hexa is 6. Number 3, nitrogen dioxide. Nitrogen is N. Dioxide. Oxide is oxygen. O. Di is 2. Number 4, phosphorus trichloride. P for phosphorus. Chloride is chlorine, Cl. Tri is 3. And lucky last, silicon disulfide. Silicon is Si. Sulfide is sulfur, which is S. And di is 2. So hopefully you got these right. So that's covalent compounds. Ionic compounds, pretty much the same idea. So an ionic compound is made of a metal and a non-metal atom stuck together. They involve the transfer of an electron or electrons from the metal to the non-metal. If you recall, metals like to give away electrons and non-metals like to gain electrons. Okay, that's why. So ionic compounds, these are typically known as salts. So a table salt is also known as sodium chloride. That's right, the chemical symbol for sodium chloride. Sodium is Na, chloride is chlorine, Cl. There's also things like copper chloride. I'm going to write copper 2 here. That's just CuCl. Cl2, I should say. This brings me into writing chemical formulae involving valencies. So copper, charge of +2, it's a transition metal. Okay, gives away 2 electrons to become positive. Chloride is chlorine, valency of -1, it's in group 17. When you stick them together, CuCl, the 2 goes down here and the -1 doesn't go down. That's the rule. You don't bring down 1s. Also, if you had hypothetically, for example, this, which doesn't happen, but anyway, suppose you had this, I don't know, actually, let's do this, calcium and oxygen. Stick them together, you don't bring down the 2s. Reason being, +2 and -2 cancel out. Compounds, be it covalent or ionic, are neutral. But when you break them apart, you get ions. These are ions. Copper, chlorine, they're ions because they're charged. Calcium, oxygen, they're ions. Compounds are neutral. That's why I write them like this, and their ions are written like that at the top. Another way to think of this is you need 2 chlorines to balance the copper, 1 copper. Cl2 means there's 2 chlorines, okay? Because -1 is -2. -2 +2 cancel out. Whereas here, +2, -2 cancel out. You don't need to do anything. Let's do aluminium nitride. Aluminium nitride is a ionic compound. Ionic compounds are made of metals, metal, which is aluminium in this case, and a non-metal, the nitrogen. Aluminium, Al +3. It's the valency, and nitrogen is N -3. Stick them together, AlN. Okay, the 3s cancel out. Then there's things like polyatomic ions you need to know. A polyatomic ion is an ion made of more than 2 or more atoms. Poly means many. So you've got the hydroxide, OH. It's got a charge of -1. That's made of oxygen and hydrogen. It's a polyatomic ion. That's called hydroxide. You need to memorize this for the exam. You've got sulfate, SO42-. I get asked in class, how do I memorize these? Well, sulfate, ATE means oxygen. It ends in oxygen. Sulfur, symbol S. So whenever you see SO4 minus 2, sulfate. It's made of sulfur and oxygen. Carbonate, similarly, minus 2. Carbonate is made of carbon and 8 oxygen. Then you have nitrate, NO3 minus 1. This is nitrate, okay, nitrogen, NIT, NITR. 8 is oxygen. Ammonium, NH4 plus. That's one you have to commit to memory somehow. Phosphate is PO4 minus 3. Okay. Then there's nitrite, which is NO2 minus. This is nitrite. With practice, you'll commit these to memory automatically, I promise. Just have to do a lot of examples. So for example, MgSO4, the way you name this, students get confused with this when they think the S and the O are separate. They're not. You get magnesium sulfate, because sulfate is SO4 2 minus. Magnesium is in group 2, if you separate them out. So it's got a valency of +2, it's a metal. Sulfate is SO4 2 minus 2. The 2's cancel out, and you get MgSO4. Magnesium sulfate. Calcium, so you've got CaNO3 2. This is calcium nitrate. Why is there a 2 there? Well, because calcium has a charge of +2, it's in group 2, same as magnesium. Nitrate is NO3 minus, stick them together, CaNO3, brackets around the NO3, because that's one big ion. And the 2 goes down from the calcium, okay, to balance the minus, so you need 2 of these to balance the +2, and you have calcium nitrate. Let's do another one, let's do Na3PO4. This is sodium Na, phosphate. Let's break it up. So this is the compound, it's neutral. If you break it up into its ions, sodium has a charge of +1. It's in group 1, phosphate, PO4 minus 3. Stick them together. PO4, the 3 goes down to the sodium, because you need 3 pluses, 3 plus 1s. So +3 minus 3 is 0. Cancel out. I'll give you some questions to do. I want you to name these compounds. Suppose in this case chromium has a charge of +3. Number 2, silver. Number 3, so you can pause the video here and try and do these by yourself. Here are the answers. Number 1, Cr is chromium. It's a transition metal. So this is chromium. SO4 is sulfate. Chromium sulfate. Number 2. Ag is silver. CO3, that's carbonate. Silver carbonate. Number 3, K, potassium. OH is hydroxide. Should have mentioned at the start, sorry, that I'm going to try and name these. Number 4, Na is sodium. I is iodine, which is iodide. Should also mention the ending. So for polyatomic ions, it's just sulfate, carbonate, they're the names. For non-metals, okay, that aren't polyatomic ions, like oxygen, iodine, it's not sodium iodine, it's sodium iodide. Replace it with IDE. Number 5 is rubidium. Not oxygen for O, but it's oxide. Okay, it's just a naming convention. So I'll leave it at that. That's naming chemical compounds.